Modern buildings are jam-packed with thousands of devices, sensors, controllers, air handlers, and they all have to work together. But how do they actually do it? How do they communicate seamlessly across different floors, wings, and even over the internet? Well, that's exactly what we're going to crack open today.
I mean, think about it. You've got one tiny temperature sensor on the 50th floor of a skyscraper, and you need its data to show up on a dashboard sitting in the cloud. How in the world does that one little piece of information find its way through a literal maze of networks and wires without just getting lost?
And the answer is actually something you're super familiar with. It's something we all use every single day, a unique address. Yep, just like the good old postal service, the BACnet protocol, which is basically the language all of these building devices speak, uses a really sophisticated addressing system to make sure every single message gets exactly where it needs to go.
To really get a handle on this, we're going to think of the entire BACnet system as a global postal service. Seriously, it's a powerful analogy, and it makes this whole complex digital network feel instantly familiar.
Okay, so here's the whole shebang. This is the complete roadmap of a BACnet address. Think of it just like writing a letter. You've got the person's name, that's the device instance. You've got the zip code, that's the network number. The street address is the MAC address. And that last piece, the object ID, well, that's like specifying which person in the house the letter is actually for. Let's dig into each one.
First up, the big one, the device instance number. This is the most important part. It's like the recipient's name on the envelope. It has to be totally, completely unique across the entire system, anywhere in the world. Think about it, right? You can't have two people with the same social security number. It's the same deal here. Every device gets its own unique ID.
Okay, so we've got the recipient's name. Now we need to know what city they're in, right? That's the network number. It's basically the zip code for our digital mail. It tells the system, hey, this message is headed for the third floor lighting network. Or maybe this one goes to the main chiller plant network. It gets the packet into the right neighborhood.
So our letter has arrived in the right zip code. Now what? Well, you need the street address to find the actual house. And in the BACnet world, that's the MAC address. It's the final local physical identifier that pinpoints the exact device on that specific street or, that network segment.
All right, now that we've got the big picture with our postal analogy, let's get into the nitty-gritty. This is where the rules of the road are, and trust me, they matter a lot. So remember that device instance number, the unique name for every device? Well, how many possible names are there? Check this out. Almost 4.2 million. That is a huge number. And that's exactly the point. It's so big that you can pretty much guarantee that every device in every building on the planet can have its own unique number. No overlaps, no confusion.
Okay, now let's talk about the local rules for our zip codes and street addresses. It's pretty simple, really. Every network number has to be unique. And then, within that network, every MAC address has to be unique. And this last part is so critical. A duplicate MAC address can literally shut down the entire network segment. Everything just stops talking. It's a total mess.
So far, so good. Our letter has made it to the right building. We've found the device. But what about the information inside the device? That's what we're really after. This brings us to Section 3, how we pinpoint the exact data we need.
This is the job of the object ID. If the device is an entire apartment building, the object ID is the apartment number. It tells you exactly which door to knock on. So instead of just addressing the whole air handler unit, you can say, I want to talk to analog input 15, which might be the discharge air temperature. It lets you pinpoint the exact piece of data you're looking for.
So you might be wondering, does someone have to program all of this in by hand? No way! The system is smart. It basically plays a game of Marco Polo. A central computer broadcasts a message that's like yelling, "Who is device 1005?" And somewhere out there, that one specific device hears it and replies, "I am device 1005. And by the way, my network is 3 and my MAC address is 12." Just like that, the system learns where everyone is and builds its own internal GPS.
Okay, theory is great, but let's get real. How does this stuff actually work out in the field? This section is all about the practical do's and don'ts. This is for all the folks who are actually out there making these systems work every day.
So here's the play-by-play for how a dashboard gets that data point we talked about. First, it does that whois/IM thing to find the device. Step 1, check. Then it asks the device, hey, what data points do you have for me? The device sends back its list of objects. From there, the software can just say, okay, give me the present value of your temperature sensor. The data comes back, gets stored, and boom, it pops right up on your screen.
And that brings us to the golden rules of BACnet. Now, planning and documenting your addresses is huge, for sure. But listen up, because these last two are the absolute deal breakers. The two cardinal sins. You can never, ever have a duplicate device instance number anywhere in the whole system. And you can never, ever have a duplicate MAC address on the same network segment. Period.
And here's exactly why those rules are so critical. If you have a duplicate device instance, it's like two people having the same social security number. The system's internal map just breaks, messages get lost. But a duplicate MAC address? Oof, that's a whole other level of bad. On many networks, devices pass around a digital token to take turns talking. If two devices have the same MAC, they both try to grab the token. The whole system freezes up. It's a complete communication meltdown on that segment.
So there you have it. This complex but really elegant digital postal service is what makes our buildings tick. It's the invisible nervous system running everything behind the scenes. But it makes you think, right? As our buildings get way, way smarter, we're talking AI, grid interactivity, millions and millions more devices. How is this fundamental addressing system going to have to change and grow to handle the future?